All right, whenever you're ready, man.
Hello there, everybody. My name is Daniel. Okay. I'm not going to say my age. We're gonna keep that a little secret for everybody.
You don't want people to know how old you are?
No, I'm
You
young.
are pretty old, to be fair.
Well, they can sense the youthfulness from my voice, but regardless,
Youthfulness.
I'm going to here today with my co-host,
Hi, I'm Nick.
and we are just two students trying to create a little science-based podcast. For the next few weeks, we're going to be two students trying to rewind 100 years of nuclear's negative connotations,
Trying to explain how it works,
Trying to
why
explain
it's good,
why it's good,
why it's bad as well.
Looking-
Giving an unbiased view. Well, slightly biased.
Slightly biased.
Because we are both studying nuclear engineering.
Yes, we are both nuclear engineering students with hopefully careers in nuclear engineering.
Hopefully.
Hopefully, potential employers are listening to this, then you'll remember our names one day. But for the next few weeks, it's going to be nuclear engineering, and then beyond that, we hope that you guys will give us some sort of
Topics you want us to cover?
Yeah, you want us to listen, where it be chemistry, physics.
Find some fun science things, maybe, that
Yeah.
happen in the news.
Yeah, in the news.
Recently trying to
not
explain
in the
it.
news, in your lives, just whatever you guys want. We're
Yeah.
here to make a journey to work, journey to wherever you guys are going, a bit more bearable.
Just if you want something to listen to while doing something in the background.
Yeah, I mean that's what I listen to podcasts for.
That's fair enough.
So I think just a little introduction. We should just give slightly more information about ourselves. So my name is Daniel. I study nuclear engineering. My favorite science isn't probably nuclear engineering, which you might say, why are you studying it, Daniel? But to which I say, I guess at university I did want to study politics and something more related to the sort of the current world. I think when it comes to science, nuclear engineering, environmental engineering, and I guess genetic engineering are probably the most political of the
Genetics, an interesting mix with the other two there.
I mean, eugenics, genetics. I don't know who comes up with these names, but
Scientists in the past.
it's the past, guys. They screwed everything up for us. But no, as I said, I probably would have liked to have done politics at university, but looking now, I'm really happy I did do nuclear engineering because it combines both science and politics. But probably my favorite part of science is probably the history of science. It's such a 2,000 plus years of history.
More than 2,000.
Oh yeah,
Humanity's been going on for a lot longer. For like 10,000.
10,000. I mean, people didn't know what the atom was back in the year 0 BC. Well, they had
They
ideas.
might have. Imagine if it's all a lie.
Imagine like 2000. Imagine the year 4000 AD. People are just gonna laugh at us.
Yeah, we're just going to be
We're gonna be the laughing stock of the 4000s.
so uninvolved with our little tools, our concrete buildings.
And so yeah, I really enjoy the history of science. It is a beautiful, beautiful discipline which is rich. But I guess the history of nuclear science only goes on for about the last 100 or so years. But I guess that's enough about me. What about yourself, Nick?
So I'm in an opposite position to Daniel here because I always really liked nuclear during my A levels, but then I kind of didn't think that I could study it like further, or it didn't clock my mind that
Yeah.
I could specialize in that field early. So with my degree, I got the opportunity to in my current year to specialize in nuclear engineering, which I snapped up straight away because I always find it fascinating. I think nuclear's our way forwards.
Oh, it's that for the last 100 or so years, it's been at the forefront of a lot of science.
Mhm.
People have been investing into it. Governments have been investing into it. But I guess the undertone of this is to just try and. There have been a lot of negative connotations of nuclear, and this podcast.
Justifiably so, but they shouldn't be taken as a norm, you know?
Yes, people should always, whenever there's a negative connotation, or
Should be
even
a balance.
even a positive
balanced
connotation,
approach, yeah.
people should say, "Why does this exist?" and go for a more balanced, unbiased opinion.
Mhm.
So I think talking about opinions, I think we should maybe sort of move on to perhaps
Our own,
our
what we
opinions.
think about nuclear.
Yeah, I think I'll go first.
After
I
you,
guess.
leading ladies.
Thank you very much. I guess my opinion on nuclear, as I said, it is a political science. It's something that affects all of our lives, whether or not, say, if you live close to a political power, if you live close to a
political
power
power
plant,
plant.
if you live close to a nuclear power plant,
So
obviously,
Westminster. The political power factory.
if you live close to, say, somewhere in, dare I say, Wales or Bristol, sort of around that region, it is going to
The region of Wales.
the region of Wales and Bristol. You know what
so
I mean.
So a big place and then a very
Like,
specific
specifically,
location.
say Swansea, Cardiff, Bristol. It is
Good.
going to influence your lives. You're gonna see it. You might be employed by it. It is something that influences a lot of people's lives, either indirectly or directly. I mean, 50 years down the line, when I'm hooked up to a dialysis machine in a hospital, who's going to be powering that
So
machine?
interesting.
Hopefully nuclear.
I'll look on your life.
Well, fine, let's say 60. Well, no, let's say 70 years. I hope to be dialysized in a 7
You
decade.
hope to be
Fine.
dialyzed?
I hope that
These
dialysis...
are weird goals you set for yourself here, my man.
I hope that dialysis happens in 7 decades' time. But back, in the future, who's going to run my machine? Hopefully nuclear power. So it is something that is a very good force, but
A good force.
just a useful force for the future. It's a clean source of energy. It combats a lot of evils in this world. Sure, it might cause some evils in the world, but it is, how can I say, it is a necessary evil for the protection of us.
Interesting. I would argue that it's not entirely clean, especially for fission, especially with all the radioactive material that we leave behind, all the nuclear waste that we still haven't found like efficient ways to dispose of it or reuse it yet.
Well, that's our job, I guess.
So at the moment, we just bury it in the ground. Yeah,
as the
we
future
could find something.
That's our job to discover it. You heard it here first, guys. We're going to find
They
the
are
future.
starting experiments about trying to transmute some of the lighter elements or some of the heavier elements that have longer half-lives, transmuting them into ones with shorter half-lives, so we don't have to deal with it for as long.
Wow, I mean, it's
like real-world alchemy. It's so cool.
Oh, good old alchemy. Feels very medieval.
So our alchemy is such a cool concept. But
should we just quickly go into what a half-life is, just for our listeners?
Go for it.
Oh God!
You were the one here wanting to give a definition.
For us, so a half-life is the time taken in, I guess, seconds. It can take years.
In time units.
In time
units. Doesn't matter.
So in time units for the nuclear activity of any sort of atom to
activity. It's a bit of a nuanced concept.
Okay, nuclear.
The amount of time that exactly half of an element's atoms disappear is a half-life.
Well, we're not going to argue on. We'll argue off camera, or we'll argue off microphone. But I believe it should be half the activity.
It is, but the activity is a measure of the atoms disappearing. So when half of them go, that's half the activity, because that's how less of them are disappearing at that moment in time.
I mean, you say tomatoes, I say tomatoes.
Mine is simpler, yours is more complex.
We'll let the viewers, we'll let the listeners
That's
decide.
fair enough.
And so yeah, let's move on to your opinions.
So I personally think nuclear is a very useful stepping stone in our energy production because it is a lot cleaner than fossil fuels. However, it's not the cleanest. I would like that renewable energy sources be the norm. However, they're not as efficient yet for our power production needs. And so I think nuclear is currently the best one we have because it doesn't have bad gaseous products like CO2, so it won't contribute to global warming as much. Yes, we do have to deal with extra waste and the involved dangers, but the safety precautions nowadays are ridiculous. So I feel like it's a very rare occurrence for a nuclear disaster to happen.
No, it's I personally believe nuclear disasters. Well, we measure risk by two things: probability and the effect. Nuclear disasters, yes, they might be incredibly high effect, but on the flip side, they are incredibly low probability. Nuclear power plants have so much there is not just one single safeguarding system. There's two. There's backups. There might even be three
backups of the backups for the backups.
For the backups,
it's just an endless string of contingencies ready to click on.
And so there might be an episode where we do discuss nuclear disasters, but as I mentioned, it is a very low probability thing. But I'd like to touch upon when you mentioned that to say renewables are the way forward, especially in this country. I think nuclear will have to be the way forward. Wind is very reliable.
Wind is a very good
especially
one.
Offshore turbines.
Offshore, yeah, the giant wind farm in the
But I guess
southern
solar
coast.
is.
Solar is less reliable for
Yeah.
the UK because it's
I mean-
not. We don't have that many good angles to catch the sunlight for a long amount of time.
Yes, especially up north.
Because once the sun goes down, that's it. Those are kaput. But wind can still generate.
Yes.
It just needs so with the tidal coast tides, with
Yes,
the
yes.
wind blowing the waves, then there's always something there ready to push the turbines.
Yes.
So it's good to have those, but solar energy isn't that reliable.
No, especially up north. I mean, the south is very sort of sunny down Hampshire and
If you're
Bournemouth.
lucky,
Yeah, if
though.
we are lucky, but comparatively, it's
Mm.
sort of the home counties down south.
Mhm.
That's where
I mean-
that's where you want solar panels.
Solar you really want in places like Antarctica or the Arctic because the sun shines there quite
Yes.
a lot for longer periods of time, and anywhere around the belt of the equator because those just get full on sunlight usually.
Yes.
So anywhere they're great.
But I mean, I don't know how happy the sort of equatorial countries will be for
True.
the UK just coming in
True.
being like.
Oh, I meant in
massive
general,
solar
not.
panels.
I'm not saying we recolonize just for solar energy.
No, we're past those days. We'll find
Hopefully.
we'll find a nice place on
Mhm.
UK soil.
Well, a good point for renewable, but this is an engineering project of dreams, would be to build a Dyson sphere to just directly capture the energy of the sun straight away.
Yeah, I think that's an incredible idea, but I think an engineering feat in the future.
Of that scale
Yes.
would be we'd have to basically eat a planet
Yeah,
for its resources, like
Oh, wow.
Mercury. Yeah, it's crazy.
I want my temperatures,
But-
you can't steal my mercury.
At the moment, I think once we strive for nuclear fusion energy,
Mhm.
that'll boost us in the right direction to start fixing some of the issues that we've caused within our planet.
Wow, like that's a really good boost forward in this podcast. Perhaps we should explain to our listeners what fission and fusion. Well, these are just jargon buzzwords we're like spouting.
Jargon buzzwords. Everyone knows what fusion is. Have you ever seen Dragon Ball? When they fuse? Yes.
Yes.
Exactly.
I'm educated in anime, but yeah.
I remember our lecturer taught us like that, didn't they?
Did they?
Yeah, our first year quantum one
Oh, yes,
with the two atoms doing the fusion dance.
Oh yes, it sort of slightly rings a bell in my memory. But yeah, I think for our listeners, I think I will stick with fission.
Please
That's
be my guest.
Slightly more what's the word? Comfortable with that.
Fissionally inclined.
Yeah, I mean, if you pardon the pun.
It wasn't really a...
I'm sorry, guys.
Please, after you.
So fission normally occurs with the heavier elements of our periodic table.
Heavier in what sense?
I mean, comparatively, there's hydrogen, the skinniest of the lightest of them.
Physically, what do you mean by heavier?
So an atom consists of, for the simplest sense, electrons, neutrons, and protons. Protons and neutrons probably give not even probably, they do give the largest contribution to mass of an atom. So the more protons and neutrons you have, the heavier an atom will be. And in terms of heavy, I am talking about atoms like, you might have heard of uranium, plutonium, these are sort of
Neptunium,
hafnium, thorium. These are sort of the common nuclear elements which we think of well heavy. But with heaviness comes, I guess, heavy responsibilities. So it's just not stable. So if we as humans were to direct a neutron towards the atom, let's say uranium-235, it would just cause even more instability, and that would cause a chain reaction where fission, they would split apart. The parent atom would split apart into two daughter atoms, and that would also release energy. This energy was then directed to heat some water, turn it into steam, and then from steam it will turn a turbine to generate electricity. And that is probably the simplest way I can describe fission. It's just about making an unstable atom even more unstable, so that
they break apart essentially, and then that releases energy.
Yeah, and that can be in a nuclear reactor. That can be, depending on how well you sort of control the supply and sort of the neutrons, you can make that reaction go on for a long time to release energy, which is what happens every day in a fission reactor. Yeah. So
our ways of generating electricity are very primitive if you think about it. We haven't changed a lot really in 1800 years.
Yeah,
like
just turning a little blade.
It's turning a magnet in a wire basically is what's happening.
Mhm.
Solar is the only really unique one, I would say,
Yeah, because
because geothermal still heats water, doesn't
yes,
it?
I think it heats. I think if I remember correctly, it is about at the end of the day, you are heating water with the heat on the ground.
Yeah,
So yes, it
to
is
turn a
still.
turbine, and so yeah, it's really weird to think about though. Now I'm thinking about it.
We should have.
Since the 1800s, we haven't come up with a new way to generate electricity except magnet in the coil.
But I mean, we're recording for electricity. If it's broke, don't.
That's
fix
true.
It.
If it ain't broke, don't fix it. Good point. Well, fusion works in a sense of you get two light nuclei. Usually, hydrogen is what we use, but you need like heavy hydrogen, which has an extra neutron instead of just a proton. So you need to fuse two of those together, and with that fusion, because the resulting element, which is helium, is more like tightly bound together, it releases energy that it needed to create as heat, and with that we can then boil off water and turn a turbine.
Wow, that's really interesting.
And it's useful because, well, nuclear energy is useful in general because 1 gram of fissionable product releases 1 megawatt a day, but a ton of coal working for a whole day only releases 0.36 megawatts.
Oh wow, look at the difference.
So it's crazy.
I did not know that.
It is really crazy.
See, everyone invest in nuclear. Coal's bad.
Now,
Coal's very bad.
an interesting thing that I've been seeing recently is how fusion is the be-all and end-all of energy production. But in truth, it's not as good as fission. Fission releases more energy. However, fusion has the added benefit of not releasing any negative byproducts.
Yes.
So in that sense, it is what we should be striving for. But in terms of energy generation, like efficiency, I think fission reactors still take the cake. However, the materials for a fusion, the fuel, is much easier to get for a fusion than a fission.
And talking about sort of the way forward, recently in the news, I've read that the UK government actually really wants to invest in a fusion power plant. I mean, it's already invested in a very big nuclear power plant, fusion power plant, has been built in southern France. That's sort of many nations are investing in that. But
There's
I think
one in Hinkley, right?
Yeah, well, Hinkley is a fission reactor. The fusion reactor is at Oxford. It's the Cullen Fusion Centre, I think. But the UK really wants to invest. It's saying £220 million. That's
220 million.
Yeah, they could pay off our student debt.
Dad's paying a whole uni student debt. Damn. And
hopefully by the year 2040, it hopes to build a commercially viable power plant for nuclear fusion.
2040, only 20 years to go.
20 years, only 20 years to go.
Crazy.
That's our future job, guys.
That might be. We could be ones working on the nuclear reactors. Probably will be, actually.
Oh, that's a nice thought to think about.
Good luck, everyone.
Yeah, we have job security. But I think 2040 is anything with science. Things do take time, especially.
Absolutely.
It's working out little things to, in the end, put all the pieces of the puzzle together to get a fully working nuclear reactor.
Because it's not just the reactor that you have to consider. You have to build all the facilities, all the control rooms, all the safety precautions.
Yes, train the employees.
It's a lot of stuff that you need to take into account.
Get water. Actually, no, we still need water for fusion. Get water from the estuary or river.
We don't need that much water for fusion reactors. You don't need to keep it cool.
There's a note to heat the.
But the actual... Yes. That's true.
So you need to find a good estuary and drain her.
Just make a dam.
But I guess... so we talked about fusion. I guess if you guys actually want to see a real-life fusion reactor, I just look up to the sun. And don't blame... Don't stare too long. No, don't stare too long, please. But if you guys just want to see a real fusion reactor in real life, the sun is the biggest visible fusion reactor that exists in the natural world.
For us.
Yeah, for us in the natural.
There are bigger stars than our sun.
Oh yeah. Well, in the Milky Way,
there are bigger stars in the Milky Way than our sun.
Yeah, I mean, I'm sitting right next to one. I wanted you to say that line, but that's okay.
You were reaching. That wasn't going to happen.
I stretched before that reach, guys. I stretched my muscles.
But for the thing with our sun, it doesn't have the same issues that we face because it's so massive.
Yes.
It creates a large amount of pressure pushing in, so there's not like a bigger barrier for the atoms to push together. Whereas here we're trying to force things that really don't want to be together, but we don't have the sun's mass to like push them together.
That's sort of like us.
Alright, fair.
I was thinking we just don't want to be together. This podcast is a liability on our friendship. We're not fat guys. I mean, you can't see us, but
Take his word for
to
it.
take our word for it.
Don't
we
take
are-
ours. I didn't say anything. I'm neutral here. You're the one reaching again.
What great chemistry we have. Genuinely great chemistry we have.
Fantastic.
And I think, I guess, linking this whole
Going back
2040
from that tangent.
I mean, that was a tangent to end all tangents. coming back to this 2040 nuclear, there have been a few articles which even contradict and sort of debate each other, which I think is a good thing.
Which is a great thing. We
It's saying-
want differing opinions. We don't just want everyone to tell us the same thing.
One article saying that nuclear energy is too slow and, dare I say, too expensive to save the climate. It's too late. No matter how much we invest into it, the effects of global warming are unstoppable. Which, do I believe that nuclear energy is the future? If it limits oil, gas, and other sort of greenhouse gas emitting energies, then of course it's one step forward into combating climate change, which I think is an absolutely great thing. It is a process that will limit it. Will it stop it? Only time will tell. It'll take a lot. It took years for global warming to happen. It will again take years for global warming, the effects to stop.
Well, I like to be optimistic, and I'd rather believe that it will fix it than we're screwed. There's no hope.
Yes, this article
I'd rather believe.
the article seems to say that the problem is not actually with nuclear itself; it's the time taken to build the power plant,
Which is understandable.
dare I say, 20 years to build this first fusion power plant. It is a long time.
Yeah,
In 20 years' time, I'm going to be
true.
20 years older than I am now. See, I still
Nearly slipped up.
still won't release my age. But another article actually says that nuclear power is a very good asset in the balanced fight against climate change, whatever balanced means.
Well, we have to balance stopping the bad energy production, but not enough to limit ourselves in any way.
Oh yes, of course, because the minute we limit ourselves with electricity, then it's
A lot of stuff is going to go downhill.
yes. Even ironically, the nuclear energy research is going to go down.
Everything will go downhill. Like if we start selectively choosing what gets our electricity, like rations, that'll be a mess.
Ooh, that's going to be very World War II rationing.
World War III, yeah, it'd be a mess.
World War III rationing the electricity.
Mm-hmm.
God. But no, I think this is. I like how the way this article ends. It says if we are truly committed to curbing global greenhouse gas emissions, we don't have a choice, and it's true. We are.
We have to take whatever is possible.
Yes, we have to. It's a necessary. I don't want to say necessary evil because, of course, fission and fusion.
Well,
do
I don't
have
think
their
it's
drawbacks.
fair to project nuclear as evil. It's not necessary evil, but I think it is a necessary step.
Yes, it's better than just sticking with oil and gas for the foreseeable future.
I mean, unless we can find a way to use the extra CO2 in a constructive way, then let them burn it. But at the moment, we're just killing our planet and ourselves.
Let them have their cake and eat it.
Mm-hmm.
But it's time to.
It's not how the saying goes, unfortunately.
Is it not?
It's you can have your
Cake.
cake.
Yes, you can have it. No, you can't have
You
your cake.
can't have your cake and eat it too.
No.
So it never
No,
really made
you-
sense.
No, so you can't.
No,
have
it is,
cake and
you-
not eat it. You can't.
No,
have cake
you
and not eat
can't
it.
have cake and eat it too. Because it's meant to be like you can't make your bed and lie in it. It's that kind of thing. Where you make your bed, you lie in it? Dude, I don't know. I'm terrible with metaphors.
There's a reason we're not food scientists.
There's a reason
or
we're not English
bakers.
literatures.
There's a reason we're not bakers or food scientists because we don't really know how food works.
How does this help us being bakers if we're talking about a
Cake.
saying to do with cake? Because that's not going to help our baking ability, is it?
But bakers-
It's a saying.
yeah, but
It
bakers
will
have
help us
their
be
own
philosophers.
sayings. Like, they have their own dozen. Like,
Your bakers, it's
yeah, we
just
have
12.
No, it's bakers
isn't it?
since 13. That's the whole point. They
Ah.
have their own dozen.
Clearly, I'm not a baker.
Yeah, but we
Don't know
have
if you
we have
can
our
tell.
dozens, and then we have their dozens.
We're not dozens.
No,
There's
but we have
two
just
of
normal.
us.
No, but we have normal dozens between us.
Oh.
When I say a dozen to you,
Yeah,
you know
I mean
what
12.
It's like if I was to say like a nuclear term to you, what's like a nuclear dozen? 200?
I don't know, a couple 100,000.
Oh, a couple 100,000. Yeah, I just when I grow up, I'm gonna get a job that makes me a nucleus dozen.
Fair enough.
Well, I wish
In
to say
monetary value or in atoms.
Well, I guess an atom. I guess.
Why would you want it in atoms? What are you
Because
going to do
paper
with
money
atoms?
probably does have a lot of atoms. In it.
Yeah, but it's not going to have uranium in it, is it?
Oh god, radioactive money. Oh. Saying that there are some really nice antique glasses. They used to. I think it's called. I must say I forgot what it's called, but there are some very nice. It's just sort of from the 20s and 30s. They used to make some very nice Art Deco sort of. I guess they were more sort of showpieces. Very nice uranium glass. That's which. Yeah, if I had a salary of just
Had
antique,
a really nice green hue to it.
yeah, if I had a whole, my salary was just antique vases, I'd be happy.
But would you just not money, just get paid in values? I mean, you'd be rich.
Yeah, I can sell them off years down the line. I think we've really strayed away from the point.
Oh, I was about to go off on another tangent. I was going to say recently, did you see the new design for the £20 note?
£20 note.
Yeah, they're making it plastic as well.
Oh yes, it's if I remember correctly, though, the £50 note comes first because
I think they're doing the 20 first because more people use 20s than they do
because
50s.
they've already chosen Alan Turing for the £50 note. I don't think the £20 note's purse has been chosen.
It has. It's someone with a famous painting. I think his last name was Turnip. Or Turner.
Turner, yes, it'll be Turner. The Turner Prize.
Yes.
Turnip.
Okay,
You did not. Oh my god. Turner. Well, I hope Turnip is proud of his legacy has been.
Didn't know who he was till he showed the note.
No, he's one of the greatest artists of English history.
Fair enough.
I mean, there's a whole prize dedicated after him.
Aye.
Are we ever going to have a prize dedicated after
Maybe.
us?
In the future.
Actually, no. I'm gonna keep your optimism. Yes, there will be a prize dedicated to us.
Absolutely. Be optimistic, not pessimistic.
It could be the Nick and Daniel podcast prize.
Well, I'd hope for it to be something to do with nuclear in the podcast, to be honest.
Wow,
You can hear the moment his heart shattered.
That's a very hated stance.
We should call it a day.
Yes, we want to keep this sort of podcast between the
Half an
average.
hour is
I'd say
fine.
the average journey from destination A to destination B shouldn't be more than half an hour. So,
Well, what are you trying to say about people who travel longer? I travel 40 minutes by tube.
I'm sorry.
You're sorry. It's
Oh
too
no,
late.
I'm sorry that the podcast is too short. You're gonna have 10 minutes of just awkward looking at people and just staring and looking,
Judging.
just twiddling. I just twiddle my thumbs.
You judge. Don't lie to me. Don't lie to them.
I won't lie to you guys. I love our listeners. The single one of you who does listen to us.
But next week, I think we'll talk about nuclear disasters. Wasn't that our plan?
Yeah, I found
Try and explain what went wrong and what we learned from them.
Yes, I think what we
would be
learned
useful.
is in any sort of disaster stuff. I think the lessons learned is probably the most important thing in the
Yeah.
world, and I 100% agree. With that.
Yep.
Well, this has been Daniel.
Nick and Daniel.
I don't know.
My name goes first. I actually know Daniel and Nick. It does come first alphabetically, doesn't it?
DNN.
Yeah, go on.
Huh?
Daniel and Nick.
Well, this has been Daniel, Nick, and
Catch you guys next week. Have a good one.